Perpetual Dreams and Hidden Realities. A Journey Through Impossible Machines. 1. An ingenious trick, the Perpetual Motion Marble Machine. You see a mesmerizing gadget. A small and steel ball glides up and around a track in an endless loop. A marvelous invention called the Perpetual Motion Marble Machine. At first glance, it seems to mock the laws of physics. Could this device really keep going forever, without stopping? If you have ever stumbled across a video of it, you might feel both confused and amazed. Is it magical? Is it a hoax? Now take a peek beneath its base. You discover a hidden battery and an electromagnet. In an instant, the illusion unravels. That endless loop depends on a concealed power source. It is not truly perpetual. Without the stealthy electrical components, the device would quickly grind to a halt. Why? Because it would otherwise violate fundamental physical laws, particularly the first and second laws of thermodynamics. Although it looks simple, this ruse underscores a larger question that has intrigued humanity for centuries. Is it possible to create a true perpetual motion machine? Or is every contraption claiming to do so just another invention with a trick hidden somewhere? 2. Why true perpetual motion defies physics. Before examining more ingenious machines, let's recap the basic scientific principles that would be broken by a device operating forever without additional energy. The first law of thermodynamics, also known as the law of conservation of energy, tells us that energy cannot be created or destroyed, only transferred or converted from one form to another. The second law of thermodynamics states that heat flows from a hotter object to a colder one unless external energy is supplied to reverse that flow. In other words, entropy. A measure of disorder tends to increase in an isolated system, preventing a perfect cycle that reclaims 100% of the input energy. For a perpetual motion machine to succeed, it would need to bypass these rules, operating at or above 100% efficiency, generating energy from nowhere or losing no energy to friction or heat. Given what we know, no such machine has ever been validated by scientific observation. Juran, a familiar example, Newton's cradle. Think of Newton's cradle, that row of steel balls on strings, often found on desks. You pull back one or two balls, release them, and watch them collide with the others, transferring momentum and energy. It visually demonstrates the conservation of energy. The kinetic energy from the first ball passes through the entire line of balls, causing the ball at the opposite end to swing out. Nevertheless, Newton's cradle is not perpetual. Each swing produces sound and heat upon impact, and air resistance saps away even more energy. Eventually, the cradle stops. This phenomenon speaks directly to the laws of thermodynamics. No matter how small, some energy is always lost to the environment, preventing any real device from running forever, unless it finds a hidden energy supply. 3. Two legendary devices, the Beverly Clock and the Oxford electric bell. Despite these seemingly insurmountable scientific laws, people across history have dreamt of building the perfect perpetual motion machine. While most of these attempts fall flat, a few devices stand out as remarkable illusions or near-endless contraptions. Let us explore two more such creations that continue to fascinate scholars. 3.1. The Beverly Clock. At the Moore University of Otago, in New Zealand, a peculiar clock stands as one of the longest-running science experiments in the world. Invented by Arthur Beverly, a watchmaker who opened his own business around 1858, This contraption has been ticking, mostly continuously, since 1864 when. The story goes that Beverly wound it only once, and it has carried on ticking for over 150 years. But is this truly a perpetual motion miracle? Not quite. The Beverly Clock harnesses subtle environmental energy. Inside its assembly is an airtight box that expands or contracts with daily temperature, and thus air pressure fluctuations. When the temperature rises, the diaphragm inside the box pushes a 450-gram weight upward. When it cools, the weight falls and wins. The clock mechanism. All you need is a 6-degree temperature change to lift the weight by 1 inch, enough to recharge the clock spring. When consistent temperature shifts do occur, the clock keeps time splendidly. However, it is not a sealed system. 1. If there is no temperature variation, the clock stops. 2. Gravity and atmospheric changes are the external energy sources driving its function. Essentially, it's a clever design, but also one that doesn't break the laws of physics. It merely exploits small, natural changes in ambient conditions. Each time the clock halts, a sufficient fluctuation in temperature eventually sets it in motion again, though it will then be out of sync and has to be manually reset. 3.2. The Oxford Electric Bell, Clarendon Dry Pile. Another notable artifact sits at Oxford University. The Oxford Electric Bell, sometimes called the Clarendon Dry Pile, because it runs on 2 dry pile batteries, believed to have been constructed in the early 19th century. Displayed since 1840, it features 2 brass bells, each connected to one of the dry pile batteries. A tiny metal clapper suspended between the 2 bells. The piles produce a low electrostatic charge, continuously repelling the clapper from side to side, causing it to strike the bells in turn. Astonishingly, this device has been ringing for about 180 plus years, potentially since 1825, the year it might have first been built. Estimates suggest it has rung more than 10 billion times. One might marvel at how such ancient batteries could last so long, especially since 1. Dry pile batteries. Use stacks of silver, zinc, and sulfur coatings that yield tiny electrical currents. But they should, in theory, deplete sooner or later. 2. The entire system is sealed, and the exact internal composition of the piles remains unknown, as no one wants to break open the device and risk damaging it. Is it perpetual? Probably not. Though the bell's unstoppable chime appears never-ending, its energy reserves must eventually fade, or the clapper and bell surfaces might wear out. Even minimal in-air friction inside the enclosure will eventually degrade the system. It is a long-lasting marvel, not a genuine defiance of physics. 4. Crookes radiometer, dancing in a partial vacuum. Perhaps you have seen a glass bulb with 4 delicate veins inside, each painted black on one side and white on the other, spinning gracefully under bright light. Known as the Crookes radiometer, or light mill, it was invented by Sir William Crookes in the late 19th century to measure radiation. When light shines on the bulb, the glass heats up and emits infrared radiation. The black side of each vein absorbs more infrared radiation, while the white side reflects it. Thermal transpiration propels the veins. Warmer gas molecules push off the black side differently than the white side, causing the assembly to spin. If you cool the bulb, e.g. with ice, you can reverse the rotation because the black side now loses heat differently than the white side. Yet this device, too, is not perpetual. It needs external energy from light or from temperature differentials. The radiometer's enclosure, while partially evacuated, is not perfectly sealed off from external interactions. No matter how enchanting its spinning vanes appear, they still rely on an energy input from the environment. 5. Elusive goal: 100% efficiency and beyond. All these inventions, from the marble machine hoax to the Beverly Clock, the Oxford electric bell, and the Crookes radiometer, embody extraordinary creativity. Yet each fails to be a perpetual motion machine because none generates new energy, nor do they operate in a frictionless vacuum with perfect efficiency. They rely on external energy or lose less than you'd expect, but never zero. True perpetual motion would require a closed box running at 100% efficiency or more, with no friction, no heat loss, and no external energy source. Physicists generally agree that under normal conditions, this is impossible. Attempting to outsmart the laws of thermodynamics has been a centuries-long quixotic pursuit. Nevertheless, bold inventors and dreamers persist, perhaps driven by hope that the grand riddle might be solvable someday. 6. The wacky world of fake perpetual machines. Over the years, inventors have showcased all manner of bizarre contraptions to claim the coveted title of Perpetual Motion Machine. Some feature rolling spheres and elaborate gear trains that appear to spontaneously rotate forever. Others rely on hidden magnets or concealed motors. Often, careful inspection reveals a hush power source tucked away under a base, or a clever arrangement that mimics perpetual motion for a limited time but ultimately fails. Why do we chase this impossible dream? For many, it's the hope of unlimited energy, an endless resource that could break humanity's reliance on fossil fuels, revolutionize power production, and transform civilization. But the second you try to extract usable energy from these forever-running devices, you're reminded of the inescapable laws of thermodynamics. The system slows, the illusions shatter. 7. A surprising exception: black holes and the conservation of energy. Could there be a cosmic loophole? Intriguingly, black holes might provide an exception to the standard conservation rules we see on Earth. Some astrophysical theories propose that black holes produce more energy than they consume under certain conditions, effectively violating conservation of energy as we traditionally understand it. One idea is to harness the concept of cosmological coupling, the phenomenon where black holes gain mass as the universe expands, seemingly creating extra energy. Imagine a scenario involving the Large Hadron Collider. If it created a tiny black hole, that black hole might evaporate, but end up with slightly more mass energy than what initially formed it, offering a net gain. Harnessing that gain could represent a perpetual motion-like system, one that uses the expansion of the universe to yield impure energy output. This might sound outlandish, yet in recent experiments, scientists successfully simulated aspects of black holes in a laboratory, even observing Hawking radiation at a simulated event horizon. Could we one day harness these discoveries to build an impossible energy source? Possibly, but until such feats become practical, we are left with hypothetical wonders rather than commercial reality. 8. The ongoing allure: why we still marvel at near-perpetual devices. Despite centuries of repeated failures, the promise of a Sorco self-sustaining engine remains compelling. Each new device, from the 18th century mechanical wonders to modern motion machines on YouTube sparks curiosity. We ask, is there a hidden magnet? Is there a concealed battery? Could it be tapping into ambient environmental energy, like a difference in temperature, pressure, or an unacknowledged radio wave? Society's fascination underscores a cultural dimension. The idea of something for nothing resonates with humans. It feels like discovering an alchemical formula that would solve energy shortages forever. The illusions captivate us, even as they inevitably break down under scrutiny. 9. Learning from the great attempts. Let's take stock of the big lessons from these near-perpetual devices. 1. Energy sources can hide in plain sight. Beverly Clock gains energy from daily temperature swings. Oxford Bell draws on the surprisingly long-lived dry pile batteries. Crookes radiometer, powered by light and heat differences. 2. Friction and other losses never disappear. Air resistance, collisions, sound production, or the gentle hum of a hidden motor all dissipate energy. Even in partial vacuums, subtle forces remain. 3. Unsealed systems exploit external inputs. In reality, none of these devices is truly closed. They feed on some external change, be it atmospheric shifts, sunlight, or leftover chemical energy. 4. The laws of thermodynamics stand firm. No experiment to date has cleanly bypassed them. We can approach zero net energy loss, but not surpass it. 5. Nature's oddities may hold surprises. Black holes and quantum phenomena could open novel doors, but true perpetual motion in the classical sense remains elusive. 10. Reflecting on the future. Will we ever achieve the impossible? So, will a perpetual motion machine ever become a tangible reality? Most scientists argue that, given our current understanding of physical laws, such a device cannot exist. Yet, physics is an evolving field. The frontiers of science, like quantum field theory or astrophysical research, sometimes deliver breakthroughs that challenge established norms. Perhaps in some exotic scenario involving advanced physics we barely comprehend, a closed system with a net gain might emerge. For now, we settle for extremely efficient machines or very long-lived devices that cleverly harness minimal energy from their surroundings, producing illusions of near-infinite motion. They may last decades, centuries, or potentially millennia. They're impressive, but are not truly perpetual, merely skillful in masking their reliance on external energies. 11. Calling all dreamers. Your thoughts? You have journeyed through the world of perpetual motion illusions and near-endless contraptions. The Perpetual Motion Marble Machine, that turned out to be a battery and magnet trick. The Beverly Clock, powered by Earth's mild temperature swings. The Oxford Electric Bell, fueled by mysterious, long-lasting 19th-century dry piles. Crookes radiometer, twirling in partial vacuum under the warming kiss of light. And a tantalizing hint that black holes might one day challenge what we know about energy conservation. What do you think? Are we on the verge of a breakthrough, or are we chasing windmills? Is there more to discover about black holes that might rewrite our physics textbooks, or is this just another cosmic tease? We invite you to share your insights. The history of invention is filled with bold attempts that seemed outlandish until they worked. Yet perpetual motion might remain an eternal dream. While you ponder, remember, real creativity thrives on curiosity. Even if it leads us to illusions or half-truths, every attempt teaches us something about the world we inhabit. 12. Parting words. Enjoy the illusions. Embrace the science. As you watch the spinning wheels of a forever machine on the internet, or gaze upon the marvels in an old university display case, let the sense of wonder wash over you. These contraptions, though limited by the laws of nature, still represent humanity's relentless drive to question the impossible. Innovation thrives at the edge of knowledge. It pushes us to imagine new solutions to the challenges of energy, efficiency, and sustainability, if you all liked. Learning about these intriguing devices, show your support, give a thumbs up, or share with a curious friend. Subscribe. Or stay tuned to follow more explorations into the extraordinary realms of science, engineering, and cosmic mysteries. Thank you for accompanying us on this winding path. Keep questioning, keep dreaming, and who knows? Maybe one day we'll find that cosmic key to truly endless energy.